watch little, like the beginning of it. All right, here we go. Yes, here we go. All right, so what I'm going to do is I'm going to pull down to the next page. So here we are. We're on question number 2. It's really the example number 2 is what it is. Okay? And you must follow the yellow brick road. You must follow my protocol. You must follow the way I work these problems. Trust me, trust me, trust me. It will help you in the long run if you will follow how I do these problems. Thomas, you with me? Thomas, you with me? Thomas! All right, here we go. It says a sample of neon gas. Whoa, everybody stop. Ashley, what element is neon? Yes. Ne, okay. And Daniel, what is the number of protons of neon? 10. Nate, how many electrons does neon have? Huh? 10. How many valence electrons, Hunter, does neon have? Valence electrons. You did. Good. Okay. How many neutrons? How many neutrons, Hunt? How many neutrons does neon have? Jaden, how many neutrons does neon have? 10. Bella, how many neutrons does neon have? 10.8. And you have a 0.2 neutron. 11.
Yeah, you see that right.
11. How many neutrons does neon have? Oh, she got it. She got it. She said, I don't know, I can't. Yeah, you can't. She said, I don't know, I can't. I don't know. You cannot know how many neutrons there are from the periodic table, right? Oh, I was just trying to see how many of us remembered from way back yonder when, like September. But you can't look at that periodic table and know the number of neutrons. Okay, so Zoe, what other, and I did that on purpose for a fact.
I think they are right.
What other piece of information do I have to have? The mass number. I have to have the mass number because that up there is an average of all the isotopes that exist. That 20.2 is an average of all the isotopes that exist. That 20.2 up there is an average of all isotopes that exist. So I have to tell you we have neon 20 or we have neon 22 or we have neon 21. I have to tell you what the mass number is before you can answer that final question. All right, so one final question though. Here we go, Tyler. What is the molar mass of neon? No. What's the molar mass? Okay, wait a minute. Tyler's answering. Okay, so about 20.2, and the unit is? Molar mass is grams. That's the number of grams found in 1 mole of neon. One more question, Lauren. How many atoms make up 1 mole of neon? I can see. Well, I can't see that. If you were a liquid or a solid, I could see a mole of neon. So how many atoms would that be? If I could see it. Okay. 6.02 times 10 to 23 atoms is what makes up 1 mole. Yes, all right. So I want you to notice one thing. One thing. I just took that name right there and I went, stop. Let's do a quick review of some old stuff. the rest of this problem says, it says a sample of neon gas occupies a volume of 752 milliliters at 25 degrees Celsius. Let's just stop. Everybody stop with me. And we're going to say here, this is a volume and this is the temperature. It's the first time, it's the very first time that I hear about volume and hear about temperature, so they are my ones. With me, Hunter? They are my ones. The question then says, or the problem then says, what volume, oh, that's the second time. So what volume, and that's my unknown, what volume will the gas occupy at 50 degrees Celsius? Oh, that's a second temperature. Second time I've read about temperature. If the pressure remains the same. So that means the P1 and the P2 are the same. The pressures are the same, so I can leave them out of my formula. Now, before we go look at what the formula looks like again, let's write down over here, follow the yellow brick road, follow my yellow brick road. Let's write down over here what we're given, okay? We are given a V1 of 752 mLs. We're given a T1 of 25.0 degrees Celsius. What must I always do, Andrew, with my temperatures? Convert it into that Kelvin. Convert it into Kelvin. Paul, you with me? Paul, you with me? Thomas, you with me? How do I convert into Kelvin? What do I have to add? 273. 273, and when I add that to 25, I don't worry about the fact this doesn't have a decimal. It's been rounded off anyway. I'm going to get 298.0 K. The next thing we read about is what volume. That means that's my unknown, so that's my question mark or my X. And then my second temperature, which I label as T2, is 50 degrees Celsius. And what must I do with that Celsius value? Convert it into Kelvin, and I add 273 to do that. So I get 323.0 K. Now what you're doing here is you're taking that 0.0 and whatever that Celsius decimal goes to, that's what the Kelvin decimal goes to. There is no little degree sign with Kelvin, it's just capital K. Anybody know the reason we have to convert it into Kelvin? Anybody know why? There's a reason. I'm just because. There are no negative temperatures on the Kelvin scale. And if I'm using numbers here, with B's and P's, there's no such thing as a negative volume. And there's no such thing as a negative pressure. So I can't have any negative temperatures messing up my volumes and my pressures. So we have to use a different scale where there are no negative values. Celsius scale's got negative values. Fahrenheit's got negative values. Kelvin has no negative values. So that's the real reason why, is because we can't have negative values. All right, so I want to give you a reason as to why we're doing that. We're not doing that just because. We're doing it for a real reason. All right, now let's go back to what is that combined gas law so we can see how those pressures go away. Combined gas law one more time. I'm going to write it down as P1, B1, T2 equals P2, B2, T1. Now, pressures, you can just leave them out. When it tells you the pressure remains the same, that means you don't have to worry about including pressures. I don't have any pressures to include because I wasn't given any pressures because they said the pressure remains constant. Now, here's the deal. Who of you remember from last week, Hunter? Who of you remember from last week? If I take the temperature and I raise it, what's going to happen to the volume? The same pressure. It's going to raise too. They have a direct relationship. One goes up, the other goes up. One comes down, the other goes down. It's a direct relationship between volume and temperature. That's how this equation was actually derived. Okay, one last thing I want you to do. Follow my yellow brick road. Any units that are alike, cancel them out. The unit that's not alike, that's all solo alone, make him feel better by circling him. That means your final answer is going to have that circled unit attached to it. Yes? With the correct number of sig figs. Good one. Good one. Good one. Y'all writing on your papers with me, right? There's no fall asleep when you're writing down on your papers, right? Okay. So let's go and let's plug and chug into here. B1 is 752. You do not have to worry about putting in the units because you've already canceled them out. T2 is 323.0. V2 is unknown. T1 is 298.0. How do I isolate V2? How do I isolate V2? Divide both sides by your T1, 298.0. 298.0, so that goes away. So in your calculator, and this is the important part for you guys. Here, I did. All right, so in your calculator, I want to make sure you know how to do this. You punch in 752 times 323.0 equals, and then you hit divided by 298.0. Everything on the bottom you must hit divided by each time. Otherwise you have to deal with parentheses, and that's not a lot of fun when you know how to do that. All right, you get a final answer of 815.087. 815.087. So 815.087 is my V2, but let's round it to sig figs and give it its units. Put that phone away. I have calculators for you. See, I don't know whether you're using that phone for a calculator or not, right? I don't. All right. How do I round that to sig figs? Let's look. 3, 4, and 4. So how many sig figs am I going to have in my answer when I have 3 sig figs times 4 sig figs divided by 4 sig figs? 3. So I take 815 and I just drop all that off, and I put my unit of milliliters. How do I know that's the unit? Because I circled it. Okay?